Okay, so firstly, my lecture or talk isn't going to be as polished as the previous one. My slides are pretty much just kind of cue cards, really, to kind of remind me about what I wanted to talk about. I'm really just here to not really tell you what you should be doing in teaching computer education, but more talk about a practice that I try and use in my lectures to make them a bit more engaging, a little bit, which I think leads to better outcomes. And then if you want to use it, use it. If you don't want to use it, don't use it. Another thing is that with Google Slides, for some reason, well, I use a lot of bullet points and I use a lot of sub bullet points. I would love if when I bring a bullet point up, it brings all the sub bullet points up, but it doesn't. So I'm going to have to press the enter keyboard a lot of times. So I feel like it's important to talk about my background because I think as an educator, kind of your lecture style is really influenced by your experiences, what you've done, etc. So I started in Aberdeen. Well, I've been in Aberdeen since 2015. I did my undergraduate here, and then I did my PhD here. One day I'll leave. No plans to just now, but well, will it be me or you first, Nigel?
Probably me.
So this kind of covers the CS. So thankfully, I am qualified to teach CS. I do have a PhD in it. I joined the faculty about a year ago, but before then, I've been teaching pretty much what I teach now, as online courses. So I've really been teaching kind of at the university level since about 2020-ish. So about when I started my PhD. I came into university with next to no kind of computer science experience. So A-level IT for anybody from England was mostly based on kind of very well, IT rather than computer science. A lot of our coursework was to do with making PowerPoints or making databases in MS Access, which thinking back, the stuff that took me probably hundreds of hours to do would have taken me maybe 2 SQL queries, so 5 minutes. And then finally, I have a background as a swimming teacher slash coach. I did that pretty much since I turned 16 as basically a job. I feel like this has given me a lot of experience with, well, one, being able to kind of disseminate information to people that really have no idea what they're talking about or don't really understand what's going on. So kind of 8-year-olds. But also trying to be quite concise in what I'm talking about. Additionally, I think there's a really good culture coming from kind of sports culture, coaching that I think would be really good to bring into university environments where it's very commonplace for us all to really be kind of observing each other, giving feedback on each other, taking inspiration from each other. You want me to stand there, Mike? Yeah. So what are my goals as an educator? I want to provide a comprehensive education in CS. So that basically means I want to teach you the skills that are going to be important for your jobs. I want to make sure that I'm not kind of academically hazing you, so giving you kind of stuff that is way more difficult than what you'd ever need to do, but also not making things so easy that you're just not learning anything. I want to ensure that I'm not just teaching the facts, so I'm not just going to essentially read you the textbook. I want to teach you the intuition behind it. So why are we doing things? And really, how can we take the information that we're learning and apply it to real world problems, etc. And I also want to ensure that the curriculum is accessible to students who come into CS with no CS background. Unless you're at really one of the top universities in the country, so your Cambridge, Oxford, etc., where they would expect you to probably be at the level that most people are at the end of their PhD on entry to undergraduate. We really want to try and make sure that our content is accessible. So that means throughout the degree program and also throughout a course, making sure that we're clear on what you need to know and that what you need to know is used in what we're learning. So why are we here? So I already kind of answered this. So to talk about issues we're facing in teaching CS, but also to essentially share tips. So I'm not saying that what I'm doing is perfect. I don't have scientific kind of studies that say my method is better than this method, etc. But I'm just going to talk about what I'm doing. And like I said earlier, if you think this is something that is useful to you or interesting, then feel free to use it. Okay, so a few questions to consider. So the firstly, why do students skip lectures? So I'm sure anybody here that's a lecturer or even a student is either the student that stops coming to the lecture halfway through the course or the lecturer that is essentially teaching to a diminishing population each week. But why? So there's a couple of factors that I've put them in quotes so I can kind of attribute it to someone else rather than saying it's a fact. But the first one, lecturers just read the slides. So this, I feel, is a fairly common complaint. And like I talked about earlier, this comes down to I'm not just here to read you the textbook. I'm here to really try and educate you. So how can we take the information from the textbook and actually use it? I can just watch the lecture at home. I don't really have a problem with this. If you feel like you learn better by watching the video of the lecture, then yeah, that's fair game. But how can we make it so that it's more useful to actually be in the lecture rather than just watching a video recording? If you're just watching a video recording, then why don't I just record all my lectures this year and then take the next 10 years off? Other commitments. So we can't really solve that due to kind of the economy, etc. It's becoming increasingly more common that students have to work, they have to go to kind of clashing courses, etc. Can't really solve this, but I'd say it's a major factor for students skipping lectures. So are lectures engaging? So this is another question that I really want you to kind of think about and then maybe see if you have an answer, maybe discuss it with me afterwards about how we can make it more engaging. Is there any point going to a lecture where somebody is just going to read you the textbook? Is that interesting? Are you getting anything out of it that you would have got by just reading the textbook? So you could have done it at your own time, maybe 5 minutes on the bus every morning over a week, and suddenly you've covered the same amount of material. But more importantly, does engaging equal useful? So I could do a lecture where I guess we just play Connect 4 for an hour or some kind of game. I think that's pretty engaging, but is it useful? So we really need to think about the trade-off between usefulness and engaging. So what is the purpose of lectures? Are we dumping information or are we disseminating knowledge? So the main difference between these is that I see dumping information is essentially just giving you the facts. Disseminating knowledge is what I feel like people are more at university for. You're here to hear from an expert in the field who has taken, well, a textbook, which may be 1,000 pages long, and has identified which bits of this are important, and is going to explain it to you, not just in the fact dump kind of way, but also why. So why did we get to this point in this course, etc.? Why are we using this? Why do we need to know this? So open question to the room, also to the online chat, if you can even hear me. What is the purpose of a programming course? Just shout out. Learn to program? Anyone else? Logic? What's that, sorry? Logical reasoning? Anybody else? Or happy? Problem solving? Yeah, so I'd say I care much more about the problem solving, or what I've called in this lecture, thinking like a programmer. So Python, etc., it's not going to be around forever. If you went back 20 years ago, you would have UC. If you go back 20 years more, they'll use Fortran, etc. They teach you the tools of the time, but the one thing that hasn't changed is the fundamentals behind it. What we are doing is we are breaking down a problem into a set of set procedures, and then we're seeing how can we then solve this problem using these procedures. Okay, So I'd argue that while it's important to know the programming language, if suddenly Python isn't the trendy language next year, if you understand how to break down a problem, then you can essentially do whatever in any language. Okay. So I think that is the main purpose of a programming course, is how to break down a problem solving, etc. But yeah, also learning to code because it's useful. So where's the standard? So when I did programming 1, many, many years ago, it was essentially 22 lectures where the lecturer just over the course of the term dumped essentially the Python documentation to us via lecture. What benefit did this offer to me? So I learned a lot of knowledge. I even had to do programming in a paper exam. So we had to memorize all of the different functionality, etc. Not great. But what did I actually learn? So I'm going to answer this. I feel like I didn't really learn how to code until second year, and then really learn to code until fourth year. So being very honest, I kind of knew a lot about coding, but in terms of actually my skills, how am I doing for time? I'm all right. In terms of actually building my skills of breaking down a problem and being able to solve it using code, because it is essentially just problem solving, I think I was pretty weak, and it really just was a moment where it clicked. So if we're just giving you documentation, we're giving you lots of tools, but are we teaching you how to use them? Are you learning to think like a programmer? So again, looking back at my history here, I think it's really important whenever you're kind of first thinking about how you want to teach a subject, think about what resonated with you when either you were learning the subject or when you were in education. So maybe it's a completely unrelated subject, but it's a way of teaching that you feel like could be applied to what we're doing today. I'm going to give an example. Anybody that's done the undergraduate here might have an adverse reaction to this, maybe a bit of PTSD. So I can remember a specific Professor Near Oren lecture in algorithms from 2016. That's pretty impressive. I don't remember a lot of things from 2016. But this specific lecture, so back then we didn't have as comprehensive of a programming introduction as we do nowadays. So there wasn't a formal pathway throughout the degree. It was very much, we've dumped all of the basics on you, go figure it out. So this lecture, we were talking about trees, so binary trees. And essentially the class, someone put their hand up during the lecture and said, I have no idea what you're talking about, essentially. So people were really struggling to understand the concept. Nir's response to this was, do you guys not know how to code? Which was, well, him finding out that yes, the majority of the class wasn't comfortable programming to kind of the level that would be expected for an algorithms course. Algorithms can look very scary if you look through the textbook. There's a lot of very complicated formulas, algorithms, etc. But when you put them into code, often they become very simple. So it's similar to like a summation in mathematics is essentially just a loop. So I think as CS students, it's quite important to really kind of ground what we're learning, the theory, in the practice, which is the code. So this lecture really stood out to me because, like I said, I kind of feel like I learned to code a little bit more in second year because Nir said, okay, we're not going to continue with this lecture. What we're going to do is we're going to build a binary tree from scratch in Python. I remember being very engaged by this, but the most important thing that I kind of learned from this was how Nir broke down the problem. So he could have just gone to a website, found an implementation of a binary tree and said, okay, here's an implementation. Cool. The thing that he did was he talked about how the operations that we want to do on it and how we build it up from scratch. So this helped. This was kind of the first time I'd seen somebody take a problem and really show how they approach it. So an expert. And I've just answered that. There's other cases of this throughout the degree. So Languages and Computability in 4th year by Matthew Collinson. I remember for some reason, the room we were in had a chalkboard and no projector. So Matthew had to write out the lecture notes. But this kind of changed lecture style from, again, PowerPoints to him explaining the reasoning behind how he was problem solving. So there's a little bit of a pattern here in that the times I was most engaged was when I'd been given the information that I needed to solve a problem. And then an expert was then showing me how to approach a problem. So it made it a lot more accessible to somebody that really had no idea what was going on most of the time. Still not sure how I got first, still not sure how I got a PhD, etc. But yeah, I feel like somebody explaining the intuition of how to go solve a problem was much more useful to me than somebody just dumping information. So what am I doing? So we've got, what's that, 15 minutes into this before I'm actually talking about the good practice that I was asked to talk about today. So I teach Programming 1, Object-Oriented Programming. I teach a lot of different programming courses that teach varying levels of programming. I really try and put an emphasis on live coding in the lectures. So another thing that I've heard someone talk about recently is that like people these days can't pay attention for more than 5 minutes, etc. So by having 5 to 6 slides of information, so the information we need to solve a problem, and then presenting a problem to the class. Give them a couple of minutes to think about it, and then solve it. So load up a code editor and actually solve it in front of the class. Talk about why I'm doing what I'm doing. Ideally, get some input from the class. Maybe they make good suggestions, maybe they make bad suggestions, and then we can talk about why it's a bad suggestion, or we don't phrase it as a bad suggestion, maybe why it's not the best suggestion. So really important kind of concept in my lectures is trying to context switch quite a bit. So try and change up the presentation of the lectures quite often just to kind of wake people back up. So as I said earlier, live coding is not copying a pre-written solution. So I'm not just going to go line by line of a solution that I wrote earlier and write it top to bottom, because that's not how we develop programs. We develop them by coming up with a different functionality, and then maybe we modify functionality as we get further through the question. I'm going to start speeding up a little bit, kind of just yapping. So live coding is working for a practice problem question that puts into use the knowledge we have just covered. So that's kind of the main kind of, what's the word, like ethos behind this, is why is the information that we've just covered useful? So if we're teaching lists, dictionaries, whatever, oh, okay, just been kicked out the call. If we're doing some kind of programming and we've just covered some kind of topic, I haven't just told you every possible method or function that can use this. I've shown you what a function is, what a method on an object is, etc. And now this question asks us, using this method, do some kind of tasks. So come up with the cost of, I think it's a vending machine I did recently. Yeah. So it's really important about how to talk about how to interpret a question. So that's the first thing that students do. Maybe students don't read the questions fully, but really how to read a question and how to see what is it actually asking me. How to break the problem down into sub-problems. So if I'm given one overall problem, it's very rarely just one task that needs to be solved. It's often comprised of multiple different sub-problems that break down into solving the problem overall. What's the naive way of solving the problem? So what is my first guess, which I know isn't correct, but I'm going to lead the class down on a tangent of let's program this, and then let's see what's wrong with it. So we're not only showing the optimal solution, we're kind of thinking about how would somebody that's a beginner solve this, and what are kind of the foot guns that they could run into. So as I talked about, programming is a tool to implement CS theory. So we're implementing what we do in the courses. I'm gonna speed through this rather than spending ages on each one. So as a result, I'm kind of still shocked how many people are still coming to the Programming on lectures. In previous years, I know that it's essentially, well, I know some courses will drop down to maybe 1 or 2 people still coming, but we started off in a big lecture theatre, probably the most students I've ever taught at once. And now we're still mostly filling the room. We've had a few people, well, mainly the people that already know how to code. That's a separate problem. But yeah, so engagement seems to be good. And also just a skill that I picked up from teaching and coaching. I have a fairly good intuition for when someone's paying attention and when they're just looking at me. I would say that looking around the lecture theatre, people are a little bit more engaged. People are responding to questions when I ask them. So I'm not just asking a question and then answering it myself. Feedback forms are positive. So this is always a nice thing to hear. Students specifically mentioning that they find the live coding in lectures helpful in order to understand how to approach a problem. Some students say that it would be good to kind of do more, and it's like, we've only got an hour. Students are engaging with the live programs. Like I said, students are answering my questions. I'm not just answering my own questions. And I've seen a marked improvement of the programming ability of the kind of cohort of students compared to what I taught last year, where I only taught the second course in the program. And I think one of the most useful things for them is that I will quite often make mistakes. I'm going to blame it on the university keyboards because they are miserable to type on, especially standing. So I'll make typos, etc., or just logic mistakes sometimes. And I think it's really helpful for the students to basically see, okay, I've had a mistake in this. How am I now identifying where that mistake is? So reading the error message, debugging my code, etc. Sometimes it's on purpose, sometimes it's not. Okay. So that covers what I've done. I'm going to talk very briefly about kind of what I think the next things I'll try in trying to make lectures more engaging, because I think more engaging means, well, learning the content a little bit better. So quizzes. So mixed on this. I've seen feedback forms that say, why on earth are you making us play Kahoot? I pay for lectures, not to spend time playing games. But I think it's probably a fairly good way of, especially in courses that are less programming heavy, essentially just providing kind of a mid-lecture break where we kind of use the content that we've just learned. So there's actually a reason to, well, understand the content that we've looked at in the lecture. I'll see how that goes, because other students have said we'd like to play more quizzes in lectures. So we'll see if that's an option. Anonymous chat. So setting up some kind of chat room, almost like I'm a live streamer, but probably paid less. I find a lot of students don't like to answer in class. They don't like to ask questions, etc., even if they are stuck. Maybe an anonymous chat that only the lecturer can see will kind of prompt these students to speak up a little bit more. I'm going to need to look into how to moderate this because I don't really want to see, I effing hate this. I'm so bored. So maybe we'll look into LLMs for that. Are practical sessions useful? So practical sessions is generally just going to a room, solving a set of questions, and then leaving. Is there a way we can make these more engaging? So can we do more like kind of interactive lectures in them, cohort size allowing? So finally, kind of my last point, do we need to learn to code? LLMs exist. This is a debate that we have all the time, where some people tell us, nope, you don't need to learn to code anymore. And then some people will say, no, it's even more important nowadays. We should go back to paper tests where we're marking on syntax. So maybe we don't need to know the exact syntax anymore. So LLMs can tell us the syntax of code. We can ask it, how do I structure an if? How do I structure a dictionary in Python, etc. But I feel like it's more important than ever to understand how to think like a programmer. So we can look through what the LLM has written. So I am somewhat in favor of LLMs. I use them quite a bit when I'm programming. But that's because I know what I'm doing. I can ask it to do it in the way that I would, and then it can go and do it for me. So it's essentially saving me time, but it hasn't removed that need to think about the problem and think about the best way to solve it. Is the LLM solving the problem with the correct approach? So just answer that. It might not be. It might be solving it in a way that I completely don't understand. And then when I want to do something later, it no longer works. How do we fix bugs? So do we just keep on asking the LLM, please rewrite this, but no bugs this time? And then just keep that cycle going until eventually my code works. Who knows? Right, so that's been my talk. I went 5 minutes over, even though I was thinking it'd be quite short. Any questions?